Hi, in this video we're going to talk about functions. We're going to define functions and then I'm going to give you problems and I'm going to teach you how to identify if it's a function or not. So before I can talk about function, I want to also mention something about the word relation. A relation is just a connection between x and y, or a connection between two variables or two sets. Okay, and there is no particular rule to it. As long as it's a connection between one variable to another variable, it's called a relation. Now, in this set of relation, there are some relations which satisfy certain conditions, and they are called functions. So a function is basically a relation. Okay, it is a relation that connects every x to exactly one y. Every x to exactly one y. So if this happens, that relation changes to a function. Okay. Um, all functions, all functions are relations. All relations are not functions. All right. Let me give you an example for that. For an example for function, let's say I have a set of I have a set. I'm going to call my first set as x and the second set as a set of y, and I'm going to say x denotes student names and y denotes student ID. Student ID. Okay. Let's say I have three kids in my classroom. Andy, Brandon, and Cindy. And let's say their roll numbers are respectively 1, 2, and 3, or the student IDs are respectively 1, 2, and 3. So every x, this is this is an example for function. So every x has exactly one y. I don't have a student who has two IDs. Everybody has exactly only one y. So this is a function. Okay, so this is what I mean by functions. Next one, an example for relation. If it's not a function and if it's just a relation, another example for that would be, let's say we have two sets, x and y, and my x is students again, students, and I have students enrolled in sports. Okay, so I have three kids in my classroom, A, B, and C, let's say, and I have two games, let's say football and track. And I have A who plays football and who also does track, and I have C who plays football. Okay, so this is not a function, this is just a relation, because A has two different sports. That means A is an x. So if I call this rule by the letter F, I have f of A would play football and f of A would also be track, right? So A has two images. So since A has two different images, this is not a function, this is just a relation. Okay, there's also another reason why this wouldn't be a function. If you look over here, B does not have an image. B does not participate in any sports here. So B has a missing image. So every x does not have a y. So here B does not have a y. So that's also a reason why this wouldn't be a function. So this is just a relation. If it's not a function, it's called a relation. Okay. If it is a function, it is also called a relation. All functions are relations, but all relations are not functions. Only if every x is connected to exactly one y, that relation is called a function. Now, let me give you some more examples. I'm going to clear the screen first. Student name and locker numbers. So I have 5 lockers in my school, let's say, for the students in my classroom, let's say. But I only have 3 students who enrolled in my class. So when I assign lockers, I will only have to assign it to 3 kids, right? So this one right now, we have to check if this is a function or not. Two things we are checking. Does every x, this is our x and that is our y, does every x have a locker? A has a 1, B has 3 and C has 5. Everybody has a locker. And do they only have only one? Okay, does every x has it and do they have only one? So that's true here. So in this case, this is an example for a function. This is, yes, it is a function and also a relation. Okay. Another example would be I have students, again, students. Let students be my x and teachers on the side, or classes or course. So I have 3 students who are taking math. There's math and English classes, okay, let's say. So A takes math and B takes English. This is an example for not a function because C does not have an image. C doesn't have an image. Another example that I can give you, again, the student and a course. We have student A, B, C and course 1 and course 2. Let's say the first student is enrolled in both courses and the other 2 students are only enrolled in course 2, like that. This case, this is not a function because A has 2 images or y's. Okay. So I think I've given you enough examples for functions. I just want to make sure that you guys are familiar with all the vocabulary here. So I'm going to clear the screen again one more time. I'm going to show you some vocab that's important for this lesson. So our x, we have x values and y values, like I stated in the beginning, x and y. The x is called the domain and the y is called the range. Also, the y is called image and the x is called pre-image. That's also another way to express the x and y. Sometimes we write points as coordinates like this, 2, 3, where this would be our x and the second one would be our y, just like how we would represent numbers on a coordinates points on a graph. Now let's talk about how we can identify functions from tables, ordered pairs, graphs, and equations. Now tables, it's very similar to the examples that I showed you. We would be given a table of x and y like this. So x values in one and y values in one, and just so that I can keep it simple, I'm going to use the same example that I used when I explained in the last screen. So as long as every x has only one y, this table right now, it is a function. What if I had an extra element here and I had a that repeated again and it was 4? So if you think about a is connected to 1 here and a is also connected to 4. So if that's the case, this table is not a function. That's how we identify functions given tables. Ordered pairs. So I'm giving you 2 sets here, set A and set B, and let's see which one is a function and which one is not a function. Okay, so let's say I have 3 comma C, this is my set A, and set B is 1A, 2B, 1C. Okay, so if I had 2 sets like this, in the first set, we know that the first elements are our x. One is x, this is an x, and this is an x. So all the x are unique. 1 only came one time, 2 only occurred one time, 3 only occurred one time. So as long as the x occurred only one time, it is a function. So this one, set A is a function. Set B, 1 is connected to A, and now I have 2, 2 is connected to B, and then 1 repeats itself again. 1 repeats itself. 1 is also connected to C. So since 1x is connected to 2y's and not exactly 1y, this is not a function. This is not a function. Only the first set A is a function. So that's how you identify functions given ordered pairs. Now let's talk about how to identify functions given graphs and equations. So first let me talk about graphs. In order to identify functions, if you're given a graph, you have to apply the vertical line test. Very simple. All it says is, if you have a graph, try to draw a vertical line through the graph. Okay, this is the graph of roughly the graph of y is 2x plus 3. I'm trying to draw a vertical line through this graph, this black graph, and if it only touches at one point, or if it only intersects the graph at one point, it's a function. Let me try to draw a vertical line on this side. The pink line, the vertical line, only touches the graph at one point. So it's a function. No matter where I draw it, it should only touch at one point. As long as it's true, this is a function. That's how you identify functions when you are given a graph. So in the second graph over here, the graph of a parabola, y equals x squared, I try to draw a line here, here. No matter where I draw a vertical line, it's only touching at one single point. No matter where I draw it, it's only cutting through one point. So it's a function. This is also a function. Here, in this one, if I try to draw a line, let's say a random vertical line here, it's touching at 3 different points. 1, 2, 3. Okay, what that means is, let's just try to write the coordinates of the first point. That's 3, 1. Let's try to write the coordinates of the second one. That looks like 3, 3 to me. And the last one, that's 3, 5, right? So for the same x here, for the same x value of 3, we had 3 different y's. So if we were trying to draw a graph of this, and I have 3 here, I would have to connect 3 to 3 different y's. So that's why this is not a function. This is not a function. Okay? So vertical line tells you if it is a function or not. Now, how do we know if we are given an equation if it's a if it's a function or not? So the equation has to be solved for y, and there should be a single expression like y equals the expression 2x plus 3. So for every x you will only have one y in this case. So first step, if you're given an equation, first step you need to do is to solve for y. Okay, solve for y. That means your equation must be in the form y equal to whatever expression. So solve for y, and that y must be a single expression. So this one is a function because y equals expression of 2x plus 3. The second one is a function because it's y equals x to the second power. This equation is a function. I only get one x for one y. Now here, this third one here, this is from vertical line test, we can already know that this graph or this one is not going to be a function because it's touching at 2 points. It's intersecting at 2 points. But how do we solve for y, this equation? So to solve for y, to get rid of the square, we have to take square root on both sides, right? So x equals y square. When we take square root on both sides, the square root and square will cancel, and we will get y is plus or minus square root of x. So when we solve for y, we did not get one single expression. We got 2 expressions here, a positive square root of x and a negative square root of x. So that's how we know that this is not a function. Okay, so this is how we identify functions in the different situations.